Evening all. I'll bounce around on Bangle and a few other related bits and pieces. I did talk about the badge last year, I think. I can't remember. The 2018 badge last year. And give you a bit of a history of where this has all come from, what it's about, and dive into Bangle.js or NodeWatch or the watch or the device, depending on which sentence I'm actually in at any particular moment. So what we've done over the past 3 years, starting back in 2017 in the top left there, we created a digital conference badge with a guy called Gordon Williams, who is responsible for the Espruino project. He's based in the UK. So the reason we talk about things like Espruino at an event like this is it's embedded JavaScript. So it's JavaScript running on teeny tiny little microcontrollers. If you look at the kind of the right-hand side there, that just tiny little rectangle, silver rectangle to the right of the screen, that's a microcontroller. It's a Bluetooth module that can run code. It can run C code, C++, Python, and in our case, it's running JavaScript. So we built this badge 2017. It was really cool. People loved it. 2018, we created the one on the right. So very, 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 very cool, beautiful badge that got people even more excited. And then this year, 2019, last year, we created Bangle. So I just want to tell you a little bit about that. So that first badge, the 2017 badge, first ever conference badge running JavaScript. So it in itself was, I suppose, unique. It was quite geeky and quite hardware focused, despite the fact that NodeConf EU is a software conference. So as you can see here, we added little prototyping areas and stuff like this, which no one used. But it kind of, we got the idea going. It was our first time around. We learned a lot. The second one, which is looking very strange in that photograph for some reason, was much more focused on sort of user experience. It's beautiful, it's got multicolored LEDs that light up the whole device and so on. But it was a big jump forward because it was connected out to Microsoft Azure via a whole array of Raspberry Pis that we had scattered around the event. And over the space of 3 days, we sent 1.2 million MQTT messages out to Azure and did interesting things with it. And then in 2019, we went, what can we do that isn't just another iteration of this? We could make a metal badge, or we could make a belt buckle badge, or we were, brainstorming, in inverted commas. And then the suggestion came, well, why not do a watch? And it was like, but the watch isn't a badge. We can't do that. And in any case, we'd have to be going around like this, showing everybody our names. And then Agatha, our graphic designer, went, Conor, we can just give them badges as well with their names on them. And went, yes, let's do a watch. So it took us quite a long time to get to where we got to with the device you see there. We went through a lot of iterations, a lot of different devices, but funnily enough, what we ended up with was a device that has exactly the same chip inside it as this, and runs JavaScript. But it also runs TensorFlow. So if you know anything about AI, you know anything about machine learning, it's running TensorFlow Lite Micro on a watch in 64K RAM. So if you're old and you have a Commodore 64 at home, it's running artificial intelligence and something with the same amount of RAM as a Commodore 64, which is, cool. I won't go into much of the history on 2017. I've already talked about 2017 and 2018. It had a lot of features. We didn't end up using a ton of them, just simply due to time, but people loved just having your name on a badge like that. And being Bluetooth based meant you can connect to it over your computer or over your phone, and that's what I'll be talking more about in the next couple of minutes. As I said, 2018 was a kind of major leap forward, just in terms of how it looked and how it felt and how people interacted with it. It also had two-way communication. So we had alerts, we had the schedule, we could live update the schedule, we could send people alerts, we could send the time, useful things like that to have on a badge. And you could set your name to obviously whatever you wanted. And then along came 2019, where, as I said, we wanted to do something completely different, and I think we achieved that. I'll go through the specs of it in a second, and this is going to if you just take 1 second here. So there's 4 bangles. rather than running 4 different apps, clicking around and making it all not work very well, I said, I'll put 4 watches on. It's just easier. I'm not sure that's right about it being easier, but anyway. So we have 4 there. This one's got the heart rate monitor running on it. It actually works relatively well if I don't move. We'll talk more about the spec on this and the kind of the decisions made around it. This one's very exciting. I'm going to have to do a little bit of fiddling with it. I won't tell you about this yet. This one is running GPS, so it's grabbing the time off GPS satellites. And this one is for my demo in a couple of minutes, actually, which I'll go into. All of them running JavaScript. Specs. So what's shocking really about this is it is an incredibly cheap device, and your people's expectations, I think, were gone well beyond, simply because it is so good for something that is so inexpensive. So it is actually IP68 waterproof because somebody tested, and it. Oh no! This is what happens when you try and do a. There we go. For anybody who's involved in the embedded world, I don't know how many of you are, it's running a Nordic Semi 64 megahertz and a RF52832. So basically it's the same chip that's in a lot of Fitbits. So that's the level of chip you're talking about. But it's running, as I said, it's running both JavaScript and it's running TensorFlow. It has a touch screen, but it's only like a two zone touch screen. It's not full touch, but you can get swipe very nicely with that. It does surprisingly have a full GPS GLONASS receiver inside it that works really, really well outdoors. Doesn't work very well indoors. The heart rate monitor, I'll be honest, it's pretty bad. It's very accurate, but you just can't move, which isn't great for a sports watch. But the data is what's particularly interesting there. So we're running, so for example, I'm going to say it runs lots of maths. It does things like autocorrelation, if anybody can remember that stuff from college. It does autocorrelation and the signal is coming from the sensor to try and smooth it out. But the data coming from the sensor isn't great, hence that it is what it is. The 3-axis accelerometer works really well, and we'll get into that in a few minutes, but you can use it to do things like pedometer, tap detect, and so on. The magnetometer similarly. Speaker and vibration motor works well. Really surprising how well the battery works. It is quite chunky, as you can see. It was one of the downsides in terms of kind of user experience. It's a little bit chunky, but you get a weak standby, which is fantastic. Try that on your Apple Watch, he said. And I know this is a simple thing, but it can be disassembled really easily. So if any of you are fans of iFixit and the complete unfixability of things like AirPods, you can actually completely take this apart with a single Phillips screwdriver and take out the battery, replace the battery, take out the screen. We've actually had to take apart about 20 of these because we flashed them badly, and the only way to reflash them when you've made a major mistake like we have is to open it up and program it in. So it's really cool that way. People love the badges. I mean, that's what makes us, that's why we keep doing this. People genuinely at the events just go, oh my God, I can't believe I got this. At an event, and they tweet about it and they write apps for it, and that's also important as well from a community perspective. As I said, it's powered by TensorFlow. We say powered by TensorFlow. It's running TensorFlow Lite Micro. We got great help from the Google guys on the TensorFlow Lite Micro team. Go buy their book. It's a brilliant book if you want to learn how to do machine learning on a $25 smartwatch. You can use everything in their book. So we got Andreas, who is one of our machine learning guys, our top machine learning person, who does amazing things and talks at the best conferences in the world on machine learning. This guy runs simulations usually on $10 million supercomputers, and got an email from me going, we have this $25 watch, do you think you might be able to get something working on it? And he did, and I'm going to try and demo in a minute. But he has a whole blog post explaining exactly how you go from, and I'll show you a little bit of it, how you go from a stupid email from someone like me to running gesture detection, accurate gesture detection on a cheap device, and that doing something useful. This is, for anybody who's done machine learning, this is Google Colab. It's really, really cool. It's basically, it's Jupyter Notebooks. It's how you do iterative development in machine learning, but you can do it basically inside Chrome. And the fantastic thing about what he's done here is you can plug in data that you have recorded using your watch and do your own gestures and do your own gestures specific to you. And right at the end, you just hit play, wherever play is up there, runtime play. It just spits out 2 lines of JavaScript at the end, and you just paste them in and you're done. So there's no compilers, there's no cross-compilers, there's no real knowledge needed other than knowing how to record a gesture, which takes about 5 minutes. So it is incredible. As I said, being able to do this kind of thing on a really cheap device is amazing. I'll jump over that for a second. This is the IDE. The IDE is based on Chrome. It runs in Chrome, in fact. It uses web Bluetooth, so you just click here and it connects to your watch over Bluetooth. That's a bunch of code, he said intelligently, which we'll get into in a minute. I will actually talk about this. I'll talk about this specifically for a couple of minutes because I have a few examples here of what's possible. And this really jumped out at me. This isn't specific to the watch, it's more about Espruino, the project, and the idea of embedded JavaScript. And you know, I spent the first 10 years of my life doing embedded software, so the idea of using JavaScript on an embedded device is idiotic to someone like me, in theory. And you talk to any hardcore embedded developer and they go, JavaScript on a microcontroller, that's not real time. True, it's not hard real time, but it can be real time in you know, practical senses. So, I've done a couple of little home projects related to the watch and related to Espruino. I'll show you 2 of them, and it really is to get the idea of how easy all of this is. I'll show you the first one now. It's not that code, but it's kind of related to it. So I'm sure a lot of you work from home. If you're remote workers, you work from home. And if, like me, you have a shed load of children, and you don't want them coming into your office when you're on a call, I have a little setup. So I have this little display stuck to my door. It's one of those little old-fashioned sort of pixel displays. It has an Espruino device connected to it. Now that's a bit of a chunky one, just because it's the only thing I had available today. And in here, so those 2 are just stuck on the wall, just, you know, battery or, you know, USB cable connector stuck on the door, sorry. This is another Espruino device. This is a Puck.js. It's only got a wire on it just to save replacing the battery the whole time. And they're both Bluetooth. I think that's the main thing. I'm going to try and do this with one hand. So basically, when I go on a call, I just press this. There's a little button inside it, and it goes red. And then a couple of seconds later, he said, hopefully, on my door, it says Conor's on a call. And then the children stay the hell out of my office, which is great. And then I press it when I'm done, or hopefully remember to, which isn't always the case. And it stops. So that's that, and I've had that for a very long time, and I've had a ton of versions of that. The first one was Lua, then it was Python, and Wi-Fi, and now it's all Bluetooth. But actually, I've also written an app for it for the Bangle. So in theory, he said, if, sorry, my eyesight, try that. Does that work? Probably not. Oh, it does! Yay! So basically, all that's happening there, and this is, seriously, there. And we'll turn it off, will we? We'll turn it off. These are available for a very low price. If you really wanted me to, I'd make them available. The whole point about that is a whole like thing. Like you could, in theory, that could be a product. That's, I don't know, 10 lines of JavaScript, and that's about 10 lines of JavaScript in total. So like that's the level you're talking at to build. You know, you start with an idea, and 20 lines of JavaScript later, you have an implementation. Now, fine, you know, there's wires here, and there's I2C, and you don't need to know about stuff like that. But, you know, it is possible. And I'll also want to show you, I'm going to jump forward to show you a video, and then I'll jump back. I love this phrase from Chris Dixon. Any of you familiar with Chris Dixon from Andreessen Horowitz, the VCs in that Silicon Valley. The next big thing will start out looking like a toy, iPhone. and then he blanks, the telephone. Western Union, this example is, Western Union did not invest in the telephone because they couldn't see how they could sell it to railway owners. So, you know, they thought it was a toy. This is a toy, but I just want to show you again what's possible. So, this is a little box, again, stating the bleeding obvious. Again, it's got an Espruino device inside it. It's got a big battery, and it's got one tiny little module there which you can't really see. It's actually an infrared LED and an infrared LED detector. And there's 3 wires connecting, you know, the Espruino device to it, and 2 wires connecting the battery. And that's the entire totality, oh sorry, there's an on-off switch. The entire totality of this. So I went onto my treadmill and I got a white marker and I made a little white mark on the treadmill belt. And then I hang this out over it. And what that little detector is actually for kids doing line following robots. You know, when kids are doing those sort of first projects they do line following robots. So that's what that detector is usually for. But basically all it does is, when it says black, it goes 0, 0, 0, 0, 0, and then when it says white, it goes 1. And then there's, again, a few lines of JavaScript that goes, have you gone 1 yet? Have you gone 1 yet? And I measure the length of my belt. And then it broadcasts the speed. And then, hit play, I wrote a little app on the Bangle, which picks up the broadcast of the speed and tells me exactly what the speed is. And the damned treadmill is telling me I'm going at 8 kilometers an hour, but I'm not, and I knew it. I knew that treadmill was wrong. I was doing 8.67 kilometers an hour on that treadmill. So, but the reason I showed that is, and I'll go back to the code actually, because where is it? The core of that code, here it's broadcasting, so that's just telling it to broadcast. And here it's just figuring out the actual, for this length of belt and the amount of time between seeing white and seeing white again, blah, 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 blah. It's maths. It's primary school maths. And then sending out the speed. The reason I built that is because I saw a massive big review of a device that does this that costs over $100 commercially. And I went, I could do that. And I did in about an hour. So, you know, again, you can do these things with JavaScript and with these types of devices. It's really easy, and that's really the point I was trying to get across there. Now, I'm going to try and do a demo. If you give me, how do I exit? Where's the escape? This is why I'm switching to Adele. There's the escape button. Just let me see if this works. I have no idea if this is going to work. Might though. So we talked about gesture control, and on the 4th watch here is running the gesture detection algorithm. And I'm going to see, this probably won't work, but we'll give it a go. It never, you know, it works at home. Yeah, okay. So let's say you've got a gesture detection algorithm running on your watch that's running TensorFlow Lite Micro. And you know, all the great brains of Google have spent all these years building all of this machine learning and artificial intelligence to enable me to stand in front of you and hopefully go like this. And then it doesn't work, does it? No, it didn't. Of course it bloody didn't. Anyway, if it had worked, we'll try it one more. That's why. We'll try it one more time. Just once, come on. See, this is why I hate Macs. I can't even get it to... So, in theory, right? There you go. Pleased with that. That took me months. Absolutely months. And it works. Now it doesn't quite work. What I really wanted to do is when I'm feeling in a bad mood, I don't have to have it preloaded up. I can just, at any moment, just get it to go, you know, and you know, off it goes. So there's artificial intelligence. So that's that. I don't know how I'm doing it. How am I doing it, Sean?
You are doing fine.
Oh, grand, okay. I have a few other bits and bobs. I was like, I won't say the most important bit. Oh, sorry, I have another bit. That treadmill thing. So, it's broadcasting speed, it's getting displayed here, but that's all fully custom. What you can do is, if you can get this guy to pretend to be a foot pod, then its broadcast could actually get picked up by a Garmin or by Strava or by, Runkeeper and so on. I'm actually working on that at the minute. It has one flaw though. To pretend to be a foot pod, you can't just do speed, you have to do cadence. So I now have another Espruino device. And this one has an accelerometer connected to it, and I have that stuck on the treadmill, and I'm now trying to detect that. So yeah, that's the final step, he said. And then means anybody would be able to build that in like literally 5 minutes, stick it on their treadmill, and have really, really accurate treadmill measurement going up to their Strava or whatever, for those of you who are into that kind of thing. Non-developers, this is not specific to us, this is not specific to Bangle. I just thought I'd mention it. That's Blockly, doesn't get enough attention. I mean, it's a Google project, it really doesn't get enough attention. It's basically Scratch for this type of scenario. But it means you can do drag and drop of blocks here and send it over Bluetooth to a watch, and it works. I think there should be more here. There are Bangle blocks being created. I've done a couple of simple things, but I want to do more kind of, I won't say complicated, but just more extensive stuff, because I've shown the watch to 9-year-old nephews and stuff, and they've lost their minds over how cool it is. There's also an emulator, so if you want to actually try and do all of this stuff, but you don't have a device, you don't have a watch, whatever, it's /IDE/emulator.html. So there's a whole script in beside LLVM, all that crack on the background there. But basically, an emulator for EspruinoJS. It obviously can't emulate Bluetooth, but it can give you the basics. I mean, that one there is me drawing speed and so on. I talked about that ease of coding, and I do think that's important. So this is the entire code, and it looks a lot, but it isn't really. This is the entire code for me displaying the speed of the treadmill on the watch. Copyright notice, icon, save it to Flash, and then this is just go and find something called a Fuel F80 that's broadcasting its speed, find a service, find the speed within that service, and then calculate it and just draw it on the screen. As I said, we're talking almost trivial amounts of work to do something useful. I think that's my kind of whole point in all of this. This is a Node.js meetup, so I suppose I better mention Node. If you want to do interesting things with the watches, with other Espruino devices, using Node, there is a module called Noble for it. The original author, it's basically, as you can see from this name here, Abandonware, the original author isn't maintaining it, somebody else has taken it over and put it under Abandonware Noble. It works really well though. We used it in 2018 for loads of stuff that we did. All of the Raspberry Pis that were talking to all the badges were running Noble, and Lino, which is the reverse. It just works, it's great. You can go scan all the Bluetooth devices in your house, you can send messages, you can read back. When I do a scan using any of this type of code, and the amount of Bluetooth low energy devices, even just in my office, ignoring just these things, is huge. Everything weighing scales, the Nest, does the Nest have it? Nest is running Thread, I think it might have BLE in there as well. So there's just a lot, but it's where if you are a Node developer and you do want to noodle around in this stuff, all you need is that module and a Bluetooth LE, either adapter, USB adapter, or any modern laptop will have it. Similarly, Node-RED, I think I mentioned Node-RED before. If you think of Blockly as being sort of for kids and non-developers, Node-RED is for people who want to do the sort of drag and drop thing, but want to do more advanced stuff. Really good for prototyping. So if you don't want to go the Noble route initially, if you want to prototype an idea, you can use Node-RED and just grab the Bluetooth block and connect it to such and such a block, and then make a HTTP request over here and do this over here, and it's all drag and droppy. As I said, it just works really, really well for people who don't necessarily want to write that much code. Back to Bangle, I know I'm bouncing around a lot. There is the original Espruino community. It's not huge, but it is quite active. When we launched the watch at NodeConf EU back in November, we had 30-something odd apps, I think. There's now 62. There's a lot of it is fun stuff. A lot of it is watch faces. But I'd encourage people to if you're interested in this, we're not selling watches. I'm not here to try and sell you a watch. But if you do want to get one, there was a Kickstarter. There's now pre-orders happening. Coronavirus has impacted delivery dates, obviously, because all this stuff's getting built in China. But there's a lot of fun to be had here. And if you're in any way interested in sports, running, any of that sort of stuff, cycling, even some NearFormers are building sort of sports watch type applications for it, because it has all the core functionality you need and costs a little bit less than my Garmin and a little bit less than your Apple Watch. And it's just so, as I said, so easy to program. Some of these apps were done at NodeConf. Like while we were there, people were able to, Jay, who works for us, did a Morse code learning app, and he did it, in one day whilst at the event. So that's the level of, as I said, ease of development. I still like that idea about looking like a toy. I have two asks, only two. If you work for an organization that might be interested in sponsoring it, we're working on 2020 now, and you think this is good. Yeah. So, exciting new form factor, because we can't keep doing the same form factor. We're going very, very, very high UX on this again. The past 3 years has been the same hardware, so I think we're going to have a big leap forward in hardware. The main reason for that, now I've become a strong believer in and I've forgotten the line now because it's late, the original hardware designer in Nintendo, and it was innovating a withered technology, that line. So basically how Game Boy and all of that used ancient tech, just used it in really interesting ways. Ditto the Wii. Wiimotes were just trivial technology. It's just the implementation and application of them. But when it comes to machine learning and AI, 64K is a real squeeze. So our actual demo at NodeConf, what I did there, we had a variation that did not work because the watch kept crashing without memory errors. So there will be more powerful hardware in 2020. We are working on a companion app as well, that's underway. Workshops, and your ideas here, so if you sponsor early enough, you'll actually get to define what's actually going on there. So that is, it's only, if it might be interesting to any of your employers.